take a look at these graphs and see how to determine the domain and range from the transformations. So we're going to take a look at this graph. So this domain restriction is going to be where it's going to be equal to 0. So it's going to be when x is equal to negative 1/2. Okay, so we can see that it's going to the right. So it's probably going to be x is greater than 1/2. So we just should double check this. Okay, looking at our domain inside, we have 2x plus 1. Okay, so this is our notation, and our transformation is going to be x minus 1 divided by 2. Okay, so we're going to have our domain at negative, the starting point is going to be at negative 1/2. Okay, and it's going to be going to the right, so it's going to be greater than or equal to 1/2. We can see that as well from our restriction of the negatives. Okay, when we have negatives inside the square root, we can't have this, so anything less than 1/2 is going to give us a negative value inside that square root. So the range in this case, our range, we're looking at it from the transformation perspective. It's going to flip, it's going to expand. So that's not going to affect our range. It's going to expand from 0, and then we're going to shift it down 3. So basically it's still going up. Okay, so it's still going up. So I'm going to have y is greater than or equal to, and the starting point is going to be at negative 3. And when we graph this, we know the graph is going to start at positive 1/2, negative 3. Okay, and it's going to go in this direction. It's been vertically expanded, and it's going to go up. So we can do the same thing with these ones here. Let's do this one from a domain restriction one, where we want to find out where is the domain restricted to. Well, we have to figure out the 0 first. It's going to be 0 is going to be at 5/2, positive 5/2. Okay, and which side of 5/2 is it going to be? Well, it's a negative coefficient on the x. It means it's been horizontally flipped. So that means that we're going to go to the left. Okay, so which means that when we talk about our domain, we're talking about x values. We're talking about x values that are less than that boundary restriction. Okay, where it's equal to 0, we want smaller values because we don't want to make it more negative. So the range, we're going to flip first, compress. The compression is not going to affect the range, but the flipping is. It's going to affect where the direction of this graph. So the plus 9 is going to raise it up. So we're going to have the starting at positive 9, but since it's flipped upside down, we need to go below that 9. And when we graph this, we have this idea where the graph starts. It's going to start at 2.5. It's been horizontally flipped, okay, vertically flipped. So it's going to go down to the left, go down and to the left. Our vertex is going to be at positive 9. So it's going to look something like that. Okay, so that's going to be at 2.5 is our x, and 9 is our y. So this one here, we can do this from a transformation perspective. We'll do the range first, because range tends to be a little bit easier. So we know that it's been expanded by 4, so that's not going to affect our range. But the shift down 6 is going to affect the range. So it's going up. It's going in the upward direction, so we want y is bigger than that boundary of negative 6. Now, as for the domain, we're going to do it from a transformation perspective here. So we know that our notation looks like this. Okay, and we want to know what the transformation looks like. So I'm going to undo this. I'm going to do this in steps because there's lots of steps here. So I'm going to end up with minus 5. Okay, I'm going to divide by 2. Okay, I'm going to shift it to the right, or sorry, to the left. So it's going to be -1. And then I'm going to divide everything by -3. Okay, so I'm going to end up with x minus 5 over -6 plus 1/3. Let's put this all under one denominator. So that's going to be plus 2 over 6. So minus, let's make this, in fact, let's make it a common denominator. Minus is going to be plus -2 over -6. Okay, so we're going to end up with x naught minus 7 over -6. Okay, so it's been horizontally flipped and compressed. Okay, in this case here is going to be, the shift point is going to be at positive 7 over 6. So the domain boundary is going to be at 7 over 6. Okay, so 7 over 6 represents our domain boundary. It's a horizontal flip because of that negative coefficient. So we're going to go in the negative direction. So we want the left side of this. So it's going to be 7 over 6. And we want the x's on that side. Okay, so when I do the coordinate, it's going to be, I'm going to shift to the left 7, divide by -6, so the vertex is going to be at positive 7 over 6. So when I draw this in, okay, I've got a vertex at positive 7 over 6, -6 is going up and to the left. So it's going to look something like that. Okay, so it's going to be the vertex at 7 over 6. -6 is a y coordinate going to the left. Okay, so sometimes it's easier to use transformation. Sometimes it's easier to just use the domain boundary, figure out where the inside is going to be equal to 0 and figure out left or right hand side. For this one, I probably would have chosen the other way around, just because it would have been, this one seemed to be particularly lots of work by having to figure out all the transformations to get to this point. Okay, but then once I've got to my transformation, I can figure out my vertex by going 7 left and dividing by -6. That's my vertex, and I know the direction because of that horizontal flip.